Here we are given a function f of x that is defined by an integral where the variable x is in the upper limit of the integral, and not just as a plain old x, but as an x cubed. The goal is to find f prime of 2. Whenever you have an integral where the variable is in the upper limit of the integral, you've got to use the fundamental theorem of calculus, but now because it's an x cubed instead of an x, we'll also need the chain rule. Break it down piece by piece. Start by letting g of x be just the plain integral with an x up there instead of an x cubed of the function 1 over 1 plus ln of t here, dt. By the fundamental theorem of calculus, we can say that g prime of x is the integrand function 1 over 1 plus ln, but go ahead and replace t with x. Since the upper limit of the integral for our problem is x cubed, define another function h of x equals x cubed. Take its derivative, h prime of x will be 3x squared. To finish the problem, we need to realize that f of x is a composition of g and h. F of x is g of h of x, and therefore by the chain rule, we can differentiate that by, first of all, differentiating the outside function g, plugging in the inside function into that, h of x, and then multiplying times the derivative of h prime of x. Using what we've already found, g prime of x is this and h prime of x is this, we can now finish the problem. We get 1 over 1 plus, plug h of x equals x cubed into this function here, get ln of x cubed times the derivative of h is 3x squared. We can then plug in the number x equals 2 into that and get 1 over 1 plus ln of 2 cubed is 8 times 3 times 2 squared is 12. 12 over 1 plus ln of 8. The answer is choice D.